Let's get this on recording.
Yeah, because he was showing me their homework.
Okay, who knows the name of this song? Oh, who knows the name of this song?
Master of the house.
Chestnuts or something like that.
Oh, yeah.
Christmas song.
It's not as interesting if you do it in your mouth.
What other 5 songs?
You missed like 5 days.
I was thinking of putting a something. I'm gonna videotape it and like put a medley of 10 Christmas carols.
You should do it.
You should do that.
If I have tomorrow, no, tomorrow I'll put it up.
Also, you should do that in the morning. Someday.
You telling me what to do?
Like on Wednesday. You should do it like next week Wednesday.
Stop listening already. Okay, in the Cartesian plane. We have the rectangular coordinate system. We can locate points, right, with x and y coordinates. You guys are used to that, right? Since pre-algebra. Okay, but is there another way?
No.
Yes. This is called the rectangular coordinate system. Yes, we have the polar coordinate system. In the rectangular coordinate system, x tells you how much to go left and right, right?
Yeah.
And y tells you how much to go up and down.
Yeah.
In the polar coordinate system, r tells you how far to go from the origin, and theta is the angle that this segment makes with the positive x-axis. So we can label a point r comma theta that would be called polar coordinates.
Hey, that sounds familiar.
It doesn't matter because I'm teaching you like you don't know anything. So the first step is you got to learn how to plot polar coordinates. Now, if you look at your packet, I gave you on the first page you got some basic notes, and then on the back I gave you some sample polar graph paper. Now, what does polar graph paper look like this? Well, you'll see in a minute. Okay, so for example, how do you plot the point 2 comma pi over 6? Well, this just means you're 2 units from the origin and you make an angle of pi over 6 with the positive x-axis. So the reason why you have these concentric circles like this is because then it's easy to figure out how far from the origin you go, right? So I always look at this first. If you measure off an angle of 30 degrees, that's pi over 6, and then you go 2 units from the origin, 1, 2, you're in. That's why polar graph paper looks like that, just a bunch of concentric circles. But ultimately, you're not going to use polar graph paper. I gave it to you. I mean, if you want to start like tonight doing that, you can, but everything's going to be drawn freehand. Yeah? You guys think you're good, yeah?
Yeah.
What about 3, 2 pi over 3? How would you plot that point? You measure off an angle of 2 pi over 3, which is 120 degrees, and then you go 3 units from the origin. On the right there. Mr. Park, this is easy. Okay, let's kick it up with that. What happens when the angle is negative? What if you have like 2 negative pi over 2? So what you do is you go pi over 2 clockwise, because that's the negative direction, and in that direction you go 2 units from the origin. So 1, 2, right there. You have to go 2 units in the direction of the angle. Now what happens when r is negative? So like what happens if you have like -3, pi?
Go the opposite.
Well, where is pi? Pi is over here, right? But then now you gotta go 3 units in the opposite direction. So 1, 2, 3 would be there. I wanna see green.
It's enough.
So you can see right away, how many ways are there of labeling a point using the polar coordinate system?
2.
No, infinitely many. Because how would you label this point? You could go 3, 0.
0.
Or you could go 3, 2 pi. Or you could go 3, 4 pi.
-3.
Or you could go 3, -2 pi. Or you could do this one too, right? Or you could go -3, 3 pi. Or -3, -pi, and so forth and so forth. So there's an infinite number of ways of labeling a point. However, the most common way would be r is positive and the angle is between 0 and 2 pi. But you don't have to, but that's just the most common. So now we know how to plot points, right?
Yeah.
Now I suppose you want the notes.
I can print them. It's okay.
Okay, so we know how to plot points now. So the next thing is we need to convert. You have to be able to convert from rectangular to polar and polar to rectangular. So we have some formulas, and now if you look in your notes, there's 4 formulas, right? And they just come from this picture right here. Look at this picture. So you can see from this picture, this is a right triangle, that r squared is equal to,
X squared plus
right, that's just the Pythagorean theorem. Tangent theta equals y over x, right? Opposite over adjacent. X equals r cosine theta. That's the same thing as saying cosine theta equals x over r, right? Adjacent over hypotenuse. Y equals r sine theta. And these are your 4 formulas that you need to know. That's key. So Monday's quiz, I guess, is just going to be on polar 1. So it should be pretty easy. Should be. So what if you have to convert from polar to rectangular? So let's say you get 4, 7 pi over 6. Convert this polar point into rectangular coordinates. To me, the easiest way is just to use the formulas. X equals r cosine theta. Y equals r sine theta, right? These 2 right here. And then you just gotta know your trig values. What is cosine of 7 pi over 6?
-1 over
Negative root 3 over 2. What is sine of 7 pi over 6? Negative half. So therefore, the coordinates of this point in the rectangular coordinate system would be negative 2 root 3, -2. Just multiply those numbers. Now, what if you're on the quiz, Mr. Park, I can't remember the formulas. Then just draw a picture. Mark off an angle of 7 pi over 6, which would be there, right? And then you go 4 units from the origin. So wouldn't this be a 30, 60, 90 triangle? 7 pi over 6 is 180 plus 30, right? And then in a 30, 60, 90 triangle, if the hypotenuse is 4, isn't this 2 and then this is 2 root 3? So therefore, the coordinates, this point would be negative 2 root 3, -2. So even if you don't know anything, just draw the picture. But I think it's a lot faster if you use the formulas. I don't know, maybe it's faster for you guys to draw the picture. Whatever, just get it. Okay, now what about the other direction? If I give you rectangular coordinates and I want you to convert it to polar, I think the best way is just draw the picture. Most books will teach you to use the formula first. It's way faster than draw the picture. So for example, here are rectangular coordinates. 3, -3 root 3. Okay, those are rectangular coordinates. Convert this to polar. So if I go 3 to the right and 3 root 3 down, right there, how far from the origin am I if this is 3 and 3 root 3? Come on. 6, because that's a 30, 60, 90 triangle, right? The hypotenuse is going to be double the short leg. And what is this angle? Oh, what is this angle over there? Since that's 60. 300 degrees. So, what are the polar coordinates of this point? 6, comma, 300 degrees, but we rather write 5 over 3, right? If you put 300 degrees, that would be correct. Degrees or radians, I don't really care, actually, but we're used to radians, yeah? Okay, let's just do one more. 0, comma 5. Convert that to polar coordinates. Draw the picture. Plot the point 0, comma 5, which is up here. How far from the origin am I? What's that angle? 90. So 5, comma pi over 2. See how better than using formulas, right? Just draw up a picture. So the first part of your homework, you have to convert from one to the other. Just draw the picture. Okay, next. If I give you the equation of a polar graph, okay, well, let's start with something easy. R equal 2 over cosine theta. Okay, now when you first start learning polar coordinates, the next thing you have to know is how to draw graphs, right? Okay, this is a polar equation, graph it. Okay, now when you read books, this is what they teach you. Make a chart, theta and r. And what you're going to do is you're going to plot a point every pi over 6, like this. So make a chart like this, which is crazy, all the way until you hit 2 pi. Okay, go. Plug in 0.
1,
2. Plug in pi over 6.
4 over root 3.
4 over root 3. Plug in pi over 3.
4.
4. Plug in pi over 2. Some of you going, what's going on?
Undefined.
See?
Undefined.
Okay, undefined, no more. And then you just keep on filling this chart in, and then, don't write this down because normal people don't do this. And then you start plotting points. So you take out your polar graph paper. Something like that. Okay, but we're going to go out freehand later. Okay, plot the point 0. Measure off an angle of 0 and go 2 units from the origin. Woo! Then measure off an angle pi over 6 and then go 4 over root 3 from the origin. I don't know what that is, Mr. Clark. Well, isn't that the same thing as 4 root 3 over 3? That's why if you know root 3 is approximately 1.7, it's a lot easier. What's 4 times 1.7?
6.8.
6.8 divided by 3.
1.15.
No.
No.
6 point, okay, 2 divided by 3. 2.2
2.5.
something.
2.5. 2.6.
Okay, so what did you say?
2.65.
Okay, somewhere around there. Okay, now measure off an angle of pi over 3 and then go 4 units from the origin. Okay, right there. And then a pi over 2, no more. And then what you do is you plot all these points, and then what you do is you connect the dots, and then you get a graph. Okay, that's kind of ugly. No. How long would it take you to do that? If you had to make this chart? Some of you still shaky on your trig values. It'll take you like the whole day to make this chart. Okay? So, the only time we ever make this chart is as a last resort. And I'm going to give you problems later on. But tonight's homework, I want you to change this polar equation to a rectangular equation. And then hopefully you know how to graph that rectangular equation. Okay, so we're not going to do this tonight. So we're going to graph tonight by changing it to a rectangular equation, and hopefully that's something we know. Any suggestions? How do I change it? Well, you have, first of all, you got to start off by knowing those 4 formulas that's written on the top of the page.
Times by cosine.
Okay, cross multiply. R cosine theta equals 2. Hey, you somebody. That's x. X equal 2. We know how to graph x equal 2. It's a vertical line. Yeah. That was the same graph we had last time, except it was like a whole day to make it. Okay, you ready to pick it up a notch?
Yeah.
Okay. Theta equal pi over 4.
Times by 4.
Look at the 4 formulas. What can I do to this equation so I can apply those 4 formulas? Tangent both sides. Why would you tangent both sides? Because tangent theta is y over x, which is 1. That's 1. So cross multiply y equal x. Hey, I know you. But doesn't that make sense? Because look, the angle is always pi over 4. So the angle is pi over 4, and you can go as many units as you want from the origin, right? You can go 1, 2, 3. No crinkling! -1, -2, -3. So you end up with that line, right? The angle is always pi over 4. R can be whatever you want it to be. Okay, what about this? R equals 2. No, 3.
Square root of.
Okay, well, if you want to change it to rectangular, you can, but just try to think about it. The distance from the origin is always 3. It's a circle of radius 3, but how would you change it to a rectangular equation? Square both sides. Because r squared is equal to x squared plus y squared. And I know that's a circle, center at origin, radius 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Woo-hoo-hoo-hoo. Right, but that's the same thing. But see, now some of you are wondering, why do we even study polar coordinates? Just so teachers have jobs? No! Because look, here's an equation of a circle. That's the equation in the rectangular coordinate system. That's the equation in the polar coordinate system. Which one looks easier?
R equals 3.
Yeah. So lots of times if you just change coordinate system, it's easier to work with. Now right now you can't see, but in the third quadrant, we're going to start studying 3 dimensions. And do you think rectangular coordinates are the only ones there are?
No.
No, there's cylindrical coordinates and spherical coordinates.
Why?
Because it's easier to work with in the different coordinate system. Okay, these are the appetizers. Now are we ready for the main course? You guys think you're good, yeah?
Yeah.
R equals 2 cosine theta. In fact, I might be doing one of your homework problems tonight. I don't want to be. At least let me change the number. Let me change the number.
Yep.
It's the same thing. Okay, I'll change it to a 4 or make that a sign. I'll make this a sign then.
Wow.
I fell into your web of deception. It's actually sign, yeah? You gave me a fake. Okay, change this to a rectangular equation. What can I do to both sides of this equation so I can use those formulas?
R.
Huh?
R.
Oh, very good. You multiply both sides by R. Not R it. You multiply both sides by R. This is R again. Multiply both sides by R. Very good. Now why? Because A, use somebody, and A, use somebody. What is this?
X squared
X squared plus y squared. And this is y. See, that reminds me of what was happening when I was correcting the papers last night. People are actually using sine in the law of cosines, even if I gave you the formula. I gave you the formula on the page, and they're still putting sine where cosine is and cosine where sine is. I don't want to mention any name. Okay, anyway, now we know what. Hey, I know what this graph is. It's a circle. How do I find the center and radius? Yeah. You're saying the obvious, but how do you get into that form? You complete the square. So you put all the x terms together, you put all the y terms together. What do I have to add to make a perfect square?
1.
Half of that number and you square it, right? You guys remember that, right? So 1, but make sure you add 1 to both sides. So you get x squared plus y minus 1 squared equals 1. Therefore, the center of the circle is at
0,
0, 1, and the radius is
1.
the square root of that number, which is 1. So, what's so funny about that? It's not even funny. Okay, you ready to kick it up a notch?
Yeah.
Okay, let me think. Oh, let's just go straight to the hard problem, Ray. This is the dessert. R equals 2 plus cosine or sine?
Sine.
Sine. So that means we're going to have a 1, a 2, and a 3, which is a 6. Okay, you don't know what I'm saying. Okay? I'm just trying to make the problem come out nice. Okay, change this to, because nobody knows what this graph is going to be, right? Anybody want to take a guess before we start?
Ellipse.
How can it be a,
Hyperbole.
not a line?
Hyperbole.
Okay, at least you're close, but Okay, nobody knows. Okay, change this to a rectangular equation. What can I do here?
Sine both sides.
No.
Cross
Cross multiply. So 2r equal, no, 2r plus r sine theta equals 6. Hey, you somebody! That's y. Is that a rectangular equation? No, because we still have r there. Rectangular equation means it only has x's and y's. Polar equations only have r's and thetas. Okay, so I got the y, so it's kind of half done.
So
What do I do with the r?
Squares, both sides.
Okay, isolate the r term like this, and then square both sides, because r squared, there's a formula for it, right? R squared equals x squared plus y squared. So square both sides. 4r squared equals 36 minus 12y plus y squared. And please don't just go 36 plus y squared. You gotta square the whole side. Hey, r squared, you somebody, huh? That's x squared plus y squared. And so you have 4x squared plus 4y squared equals 36 minus 12y plus y squared. Now we recognize this as, gosh, no!
Oh,
Yay!
look at this.
Ellipse! What's going on? Ellipse. Oh my gosh. Okay, maybe you don't recognize it in this form, but you have to put it in standard form. Now, I don't expect you to find all the parts of the ellipse, like remember the vertices, the endpoints of the minor axis, the foci, the directrices, and the eccentricity. I don't expect you to do that. I expect you to graph this though. So you have to be able to put this in standard form. So what do? You put all the x's together, and you put all the y's together, 3y squared plus 12y, and you throw the number on this side.
you make it 1 at the end.
Yeah, at the end. Okay, what can I do over here? Factor out the 3, and you get y squared plus 4y. Leave a space to complete the square. Okay, what do I have to add right there to make a perfect square?
4.
You take half of that number and you square it.
4.
4, but you actually added 3 times 4, which is 12. So you have to add 12 to both sides. So this is what you got. 4x squared plus 3 times y. Now it's taking shape, yeah? Equals 48. But if you remember anything from last year, what do you need this side to be?
1.
1, right? So how do I make this side 1?
48.
Subtract 47 from both sides, or divide by 48?
Divide by 48.
You divide by 48, and so you get x squared over 12 plus y plus 2 squared over 16 equals 1. How do I know it's an ellipse?
Because they're different.
There's a plus sign.
Oh, I guess because they're different.
Yeah, because if they were both the same, it would be a circle, right? With a plus sign. What if there was a minus sign there? Then it would be a hyperbola. So I don't expect you to know all the parts, but you got to be able to graph. Okay, so that's why I'm doing this problem, because the last 3 problems on tonight's homework, I believe, are conic sections. One is a parabola, one is an ellipse, and one is a hyperbola. Okay, where is the center of this ellipse? Where's the center? 0, negative 2. It's like you guys never learned conic sections before. How much do I go left and right from the center? You look at the square root of that number. What's the square root of 12?
2 or 3.
3 point something.
No,
Shouldn't it be?
no, 2. It's negative 2.
Why don't you
No,
look before you
negative.
open? Why don't you look at the board before you open your mouth? There's 0, negative 2. So, how much do I go left and right? The square root of 12, which is 3 point something. So you go 3 point something left, 3 point something right. So wooga and wooga. How much do I go up and down?
4.
Square root of that number 4. So you go 4 up and 1, 2, 3, 4 down, and then ellipse. Yeah, that's kind of what I do. There. A little better? So that's what I expect you to do, graph. Now, in the 3rd quarter, the first thing we study are conic sections. So not only do you have to graph it, you got to be able to find the center, the vertices, the endpoints of the minor axis, the foci, the directrices, and the eccentricity.
don't think we learned this.
I'm gonna teach you everything, don't worry. Oh, so out of all of those parts, what did you guys learn last year? Did you guys learn center?
Yeah.
Vertices,
Yes.
and points of the minor axis?
Yes.
Foci?
Yes.
Directrices?
Yes.
Oh, you did learn directrices?
No. Yes.
I think only parabola, right? You didn't do
No,
that.
we learned directrix.
For a parabola, but what about ellipse?
Oh, yeah.
Yes.
An ellipse has one directrix here and one directrix there. Well, see, why do you even study the focus then? Because anytime you have a conic section, there's a focus, there's going to be a directrix on the other side. So if you study the focus, it's kind of incomplete if you don't do directrix. Okay, so that's what I expect. Okay, let's go to the test. Now you'd be happy to know I actually came early this morning and I corrected the homework. Some of you did not do well on the homework, so I gave you a pity score.
What's the pity score?
Because I didn't want to give negative. So I gave you a pity score.
How do you give a negative score?
So, when I pass back the test, the number in the upper right-hand corner, that is absolutely your current average.